Alright, we are moving into 8.2 after learning about 8.1, which was dilations. So we're going to learn about a couple more transformations in this video, and how to do multiple transformations for one figure. So let's talk about some definitions first. So now a dilation, as we talked about in 8.1, is a transformation that preserves the shape but it does not preserve the size. So if you were able to watch this video that we talked about, if you were able to watch this video, this is a dilation, right? So you can see the dilation enlarges or reduces the size of the figure. Now, so the shape is preserved. It's the same exact shape, but the size of the shape is changing depending on the factor of k. So that is what we called a dilation. Now we're going to introduce different sort of transformations, specifically translations, reflections, and rotations. So we'll talk about what those are. But let's talk about what a similarity transformation is. So similarity transformation, this is a transformation so it's a transformation sorry, I need to rephrase this. This is a similarity transformation is a dilation or a composition. This just means more than one. A composition of rigid motions and dilations. Rigid motions means that it preserves the shape, so the shape is the same. So, for example, a translation is just like a movement. It's like you take like a square and you move the square in a direction. A reflection is you could take a square and you can reflect it across lines, and a rotation is that you can rotate the square. So the shape of the square is still the same. So that's what it means by a rigid motion. Now a dilation is a non-rigid motion, meaning that the shape doesn't change, but the size does change, the size of the shape. So I guess I should say that the rigid motion does not change its size or its shape. Just changes kind of, you could say, location, I guess you could say. So a similarity transformation is a composition of dilations and these three others. So you can have more than one of these. And then similar figures is like you could say so two geometric figures are similar figures if and only if there is a similarity transformation, if and only if there is a similarity transformation that maps one of the figures onto another. So here's what that means. So it's like you're taking a figure. So let's say we take a triangle. And then let's say that we rotate the triangle and then enlarge it with a dilation, so we make it bigger. These are what we call similar figures. These are two similar figures. And they're two similar figures if and only if there is similarity transformation, which is a compilation of rigid motions and dilations that maps one figure to another figure. That's how they're similar. Okay? So in this example right here, let's graph the triangle ABC vertices right here. So point A is negative 4, 1. B is negative 2, 2. C is negative 2, so negative 2, 2, and then C is negative 2, 1. So this is A, and then we have B, then we have C. So this makes a triangle. So there's a triangle. So let's perform these transformations. Okay, so this is a new one, a translation. So this is what you do when you have a translation. Simply what you do is exactly this right here. You take x and you add to it what it tells you to add. So basically what's happening to these points right here is that the x is shifting to the right 5. The y is shifting up 1. So this is a translation, is a movement, it's a shift. So we're taking this triangle and we're going to move it. So again, these right here together is what you call the similarity transformation. So these are similarity transformations. Again, it's a composition. So this is a composition of a translation and a dilation. Okay, and so first what we need to do is do 1 and then 2. So we take A, so A prime, we're going to add 5 right here. And then we're going to add 1 to the y. So add 5 to the x, add 1 to the y. Add 5 to the x, add 1 to the y. So what that's going to look like is going to be negative 4 plus 5, comma 1 plus 1. B prime, it's going to look like negative 2 plus 5, comma 2 plus 1. C prime will be negative 2 plus 5, and then 1 plus 1. So then A prime after the translation will be at the point 1, comma 2. B prime will be at the point 3, comma 3. C prime will be at the point 3, comma 2. So let's graph these. So at 1, comma 2, at 3, comma 3, and 3, comma 2. So these are the new points A, B, and C. So here's A prime, B prime, C prime. So that's one transformation. So notice that the shape did not change at all. Or the shape didn't change and the size didn't change. But now we have a dilation. So now we're going to take these points and we are going to perform the dilation, which has a factor of 2. So now I need to take A prime, which is over here. I need to do 2 times by 1. And then this is going to be 2 times by 2. B prime, which will be 2 times by 3. 2 times by 3. C prime, which will be 2 times by 3 and 2 times by 2. So now A prime, B prime, and C prime will be 2 comma 4, 6 comma 6, and 6 comma 4. So 2 comma 4, 6 comma 6, oh, and 6 comma 4. There we go. So then here's A prime, B prime, and C prime. So you could see that it took, this is what we call two similar figures. It underwent a composition of changes. So we went here, then to here, and these are similar figures. Okay, so that is what happens with a translation. Now, you can try this on your own right here. A translation and a dilation here. That's going to be for you to do. I'm going to come here and talk about reflections. So first of all, let's graph what we have. So we're given these 3 points. So r is 12, y is 8. And then we have 8 comma 0, and then 0 comma 4. Okay. Now the first set of transformations is a dilation where everything is divided by 4. So these are divided by 4, divided by 4, divided by 4. So r prime becomes 12 divided by 4, which is 3. That's 2. S prime is 2, 0. And T prime is 0, comma 1. So I'm going to graph these. So here's the dilation at 3, comma 2, at 2, comma 0, and at 0, comma 1. So this is a reduction by a factor of 4. Alright. And then now this is a reflection in the y-axis. So reflection in the y-axis. So let's say you take a mirror and it's going down the y. Now how does that change your coordinates? So we're taking this and we're mirroring it across this orange line. So this point right here, it's 1, 2, 3 points over. So that means it's going to be 3 points over this way. So that means its new coordinate has to be negative 3, comma 2. S prime, which is right here, is 2 points over. So now it's going to be 2 points to the right. So now it's going to be negative 2. So 2 points to the left. T prime, so it's on this mirror line, so you can't really exactly reflect it, so its point doesn't change. So here's the thing to notice about a reflection in the y-axis. The y value flipped. The sign of the y value changed from positive to negative. So right here it would look like right here, right here, right there. So it would go from there to there, there to there, there to there. So here's something important to note. Reflection in y, flip the sign of the x value. The x value, so reflection of the y, change the sign of the x. Reflection in x is to flip the sign of the y, of the y value. So what that will do is it will change it from here and move it down here. So again, you're changing the y value. Y is vertical. Okay, so that's how you can do reflections. Alright, now here we're going to talk about rotations. So let's first graph our x, y, and our z. So x is at 9, 6. or sorry, yeah, 9, 6, so 9, 6, so the point right here, y is at 3, 3, and z is at 3, 6, right there. Alright, now we're going to rotate about the origin, so here's the origin, so we're going to take this and we're going to rotate it 90 degrees, so all the points need to go 90 degrees. Now, first thing to note about rotations. Unless specified otherwise, rotate counterclockwise. Counterclockwise. Unless specified otherwise. So counterclockwise means this way. Okay? So rotate counterclockwise unless specified otherwise. Okay, so this is kind of similar. So up here we change the value of the x when it's a reflection in the y. Here you change the value of y when it's a reflection in the x-axis. So there's a similar kind of a change. So for this one right here, what you do with these values, what you can do, because it can be difficult to kind of see how you rotate this 90 degrees. It can be really difficult to see that and to map it to a new point. This right here has to rotate 90 degrees. So that means that this point is going to be in this quadrant right here, but it's kind of hard to see where that point is. So here's how you can find your point. So to find your point, change the value, flip the x and y spots. Okay, so flip the spots of x and y and flip the sign of y. Okay, so essentially what this means is that if you have a point of x comma y, a rotation means that it's now negative y comma x. So a rotation that is counterclockwise. It's also important to note, rotation that is counterclockwise. So for instance, let's take x prime. So here my x is 9 and my y is 6. So my x prime, I'm going to flip them, so it's going to be 6 comma 9, but I'm going to change my y, which was 6, to negative. So my point here for x prime will be at negative 6 comma 9, so up here. So that's this point right here. So this point rotated 90 degrees ends up right here. So you can see that that makes a 90-degree angle right there. Okay, and then my y prime, so these are both, this is x and this is y, they're both 3, so if you flip their spots it's not going to change, but I need to change my y, which is 3, to negative. Okay, so then negative 3, positive 3, which is right here. So again, it was right here, but now rotated 90 degrees. You can see I make a right angle right there, so it's rotated 90 degrees. And now my z prime. So here's my x and here's my y, so I need to flip this over, make it negative, and then this one needs to come over here, so negative 6 comma 3, so right there. And I don't know why I've been erasing all my other points. Negative 6 comma 9, so right there. So again, this point right here, which was right here, has been rotated 90 degrees. So you can see the 90-degree angle right there. And then, thus, my transformation figure that is rotated 90 degrees counterclockwise looks like that. Now that's one of the transformations. Now the other transformation is a dilation by 2/3. So I need to multiply everything by 2/3 from here. So my new x prime will be negative 6 times by 2, which is negative 12, divided by 3, which is negative 4. And then this is going to be 18 divided by 3, which is 6. Y prime will be negative 2, comma 2. Z prime will be negative 4, comma 2. So then my final figure will be at negative 4, 6, at negative 2, 2, at negative 4, 2. So there you go. It's a dilation by a factor of 2/3, which means it's a reduction, so it gets smaller. There you go. Okay, so make sure that you know these notes right here on the left-hand side. That's how you perform these type of transformations. Okay, now coming down here to this example, we are going to describe a similarity transformation that maps the trapezoid PQRS to trapezoid WXYZ. Alright, so let's see if we can describe the transformation. So first of all, notice here that it looks like it's mirrored about this y-axis, right? That's what I noticed first of all. Because this tip right here, this slant is going down towards the right, now it's going up towards the right. So I'm going to first state that it's a reflection in the y-axis. So a reflection in the y-axis. Alright, so basically now let's see what happens when I reflect it in the y-axis. So this goes, it's going to go to here, to here, to there. So I'm trying to see how it's mapping from here to here. So I have to reflect it, and now you see that my reflection puts it in the same sort of direction. But now, obviously, this green figure is smaller than my blue figure on the right. So obviously there's going to be a dilation. So I need to know what the factor is though. So what I do know is that x is at the point 1, 1, and its congruent or corresponding point is at it's at 1, 2, 3, 3, 3. Alright, and then my W point is at 2, 1. My Z point is at 2, negative 1. And my Y point is at 0, negative 1. So their corresponding points are at, this would be at 6, 3, I believe. Z is at 6, negative 3. And my Y corresponding part is at 0, negative 3. So there's a dilation happening from here to here, and hopefully you can see it. The dilation, or I guess I should say the dilation is from here to here, right? Because I'm trying to get from the larger figure to the smaller figure. So this is my larger figure, this is my smaller figure, so you can see that everything is bigger by a factor of 3. So that means that my dilation has to be by 1/3. So dilation by a factor of 1/3. Because that's how I get from here to here, is by multiplying everything by 1/3 or dividing by 3. Okay, so let's try a couple more over here. So, first of all, what's easiest for me to help me see is to just list the points. So from n, I start at 0, 6. At m, I'm at 0, 4. At L, I am at 6, 6. Alright, now notice here, first of all, then I guess I can write n prime. So n prime is at 4, 2. M prime is at 4, 1. And L prime is at 7, 2. Okay, I'm going to move these off here to the side a bit. So first of all, notice that the shape is different, right? So this is a side length of 2, this is a side length of 1. This is a side length of 1, 2, 3, 4, 5, 6. This is a side length of 3. So obviously, n prime, and L prime, that triangle is 2 times smaller. So I know that I have a dilation by a factor of 1/2. So what I'm going to do here, first of all, so dilation of 1/2, of a factor of 1/2. So that means if I take n and I divide it by 2, I get n prime, which would be at 0, 3, m prime, which would put at 0, 2, and L prime, which would put at 3, 3. So let's map those points. So 0, 3, m prime with 0, 2, and then at 3, 3. So you can see now that our figure is the exact same size as this one right here, which means that it's only in a different location. So all that's left here is a translation. So it's a translation, and let's see how many units are we moving. So from here, n prime, I have to go 1, 2, 3, 4 units to the right and 1 unit down. Same with L prime, that's 1, 2, 3, 4, 1 unit down. 1, 2, 3, 4, and 1 unit down. So my translation is 4 units right, 1 unit down. There you go. So for 5, so again, we're going from A to B. So let's see, first of all, what I notice is that it's reflected across the y. So reflected across the y. So if I reflect this across the y, then my figure goes there to there, there to there, there to there. Now notice that my figure is larger. So this right here is 2, and this is 2 right here. And this right here is 1, 2, 3, 4, 1, 2, 3, 4. So obviously it's a dilation by a factor of 2. Now for 6, okay, now notice that if I were to reflect it, so I'm going from here to the smaller image. So if I were to reflect it, that would put me something like this, which is not the same image. So notice also that first of all, Q and Q prime are in the same spot, but Q and T is horizontal on the smaller figure on the left, but on the bigger figure on the right, Q and T are vertical, which has to mean that in order to get from this position to this figure to this figure, I'm going to have to rotate 90 degrees, because I need this line to match up with this line right here. So that's got to be my first one. So it has to be a rotation counterclockwise, (90°). And I guess you should say about the origin. Alright, next thing that we notice is that it's smaller, so I'm going to compare the side lengths. So this has a side length of 1, this has a side length of 1. Wow, so that's SR, S prime, and R prime, and this is T prime and Q prime. So S and R has a side length of 3, this has a side length of 3. So it's obviously reduced by a factor of 1/3. So a dilation by a factor of 1/3. Okay. And there you have it. That should pretty much do everything for this unit right here. So it's a lot to take in for this week. So please let me know if there are any other questions.